Hello everyone and welcome to the NX A to Z article, NX Cam Milling Tips Part 1. Obviously we'll be doing a couple of these, and today we're going to talk about toolpath optimization, I guess, both in the sense of optimizing the toolpath, in terms of extending the life of the cutter, improving the surface finish, more accurate operations, more accurate finished part, but also optimizing your toolpath in terms of efficiency. So programming efficiency, being able to finish the entire part with one operation, and being able to understand, what kind of tool you need to machine as much of the part as possible. So the features that we're going to be talking about are optimized feed rate, report shortest tool, optimized cut levels, and cutting between levels. Alright, so the first is optimized feed rate. And what optimized feed rate does is NX looks at the 3D in-process workpiece and looks at your toolpath and analyzes the engagement of the tool with the in-process workpiece to determine the material removal rate, and then it will adjust the feed rate to try and maintain a nominal material removal rate. So what this does is it extends the life of your tool, improves the surface finish, and also improves the accuracy of the finished part, because you don't end up with the tool having a constantly fluctuating, material removal rate. So if we look at this operation here, this is just a typical Z-level profile, and we list this toolpath. You can see we've got a feed rate up here somewhere. So there's our feed rate, 10 inches per minute. And that's probably the only time that comes up. Only one E. So we've got one feed rate called out at the beginning of the operation, which is pretty typical, right? So now if we optimize this feed rate, we can just go to right-click the operation, go to Toolpath, Optimize Feed Rate. You can also do this for a group of operations. So you can select a program group or a tool from the machine tool view. You can select a tool to optimize all the feed rates for a given tool. We're just going to select this one operation, optimize the feed rate. So this is pretty quick, but you can imagine, that takes a few seconds or whatever. But if you have a really huge toolpath, that might take a little bit of time, so you got to be aware of that. And now if we list this again, we're going to see quite a few different feed rates. So there's 10, 7.9. Let's see if we can just find these here. 1537, 2010, 2010, 20. So it's adjusting the feed rate to maintain a constant material removal. Now, if we generate this operation, it's going to go back to being just the single feed rate call out at the beginning of the operation. So if you want your operation to always have an optimized feed rate, then you can open up the feeds and speeds dialog from within the operation and check the optimized feed rate when generating box, and then when you generate the operation, it will also optimize the feed rate. There is also a customer default that allows you to optimize the feed rate for every operation all the time. So there it went ahead and generated it, and now it's doing the feed rate optimization. So I don't have to worry about remembering to optimize the feed rate every time I generate. And if I want that to be the case for all operations, then I can go into the customer defaults, select the operation item under manufacturing, optimize feed rate tab, and I can check that box, and then all my operations will have optimized feed rates. Just one other note, you can actually add an optimized feed rate column to the operation navigator, so you can just see at a glance whether or not your operations have optimized feed rates. So if you're done creating all of your operations and you're ready to post-process, but you want to know which ones have optimized feed rates, you can just check the operation navigator column and see quickly if all the operations that you want to have optimized feed rates do, and then if not, you can just optimize the feed rates for whichever operations you need to. Okay, so that is optimize feed rates. The next feature that I want to talk about is report shortest tool. Again, this is accessible by right-clicking an operation and going into the toolpath section here, and then selecting report shortest tool. So your tool definition, the tool that you're using for the operation that you want to report the shortest tool, it has to have a holder defined. And what NX does is it looks at the in-process workpiece, it looks at the tool, and it looks at the holder, and determines the minimum distance that the tool can project from the holder in order to prevent the holder from colliding with the in-process workpiece. And the benefit of this is, it allows you to put the tool as far into the holder as you can, which makes the tool setup more rigid, which extends the life of the tool again, improves surface finish, and also improves the accuracy of the finished part. So right now, NX is actually creating the in-process workpiece, which probably is going to take a while. That's a big operation, so let's try this one instead. There's a lot less to check on this one, a lot less cutting moves to check. Again, the report shortest tool, there is a column for the operation navigator. So you can see, once you've done this, the column gets populated in the operation navigator, and then you can know, what the shortest tool is for all of your operations just by looking at them. So if you're using the same tool for multiple operations, then you can see quickly what the, what the limit is as far as how far the tool needs to project from the holder. Okay, so we can see that the shortest tool is 2.294. So that's not the length of the tool, that's how far out of the holder the tool needs to be. And so again, then we can do operation navigator, shortest tool length, and we can see shortest tool length there. And from the machine tool view, you can imagine if you had 4 or 5 operations using the same tool, you could quickly see all of them at once and know, what the minimum projection is. Okay, so the next couple of features we're going to talk about have to do with optimizing the cut levels on a Z-level profile operation. So Z-level profile is a level-based finishing operation. And typically it's intended to be used for inclined faces, but there are a couple things that you need to do to get a consistent surface finish on a part with faces that aren't all at the same angle. And then you can also actually use the same operation to finish horizontal faces as well. So the first thing we're going to talk about is optimized cut levels. So if you look at this operation type, you can see we've got a constant depth of cut here, which is fine on all these faces here because all these faces are more or less the same incline. But these faces, obviously there's going to be a much taller scallop height on these faces here because they're at a much less steep of an angle. So in the common depth per cut dialog or drop down, you've got scallop and constant for the two choices. And I was at constant 40 thousandths. I'm going to change it to scallop, and then I'm going to regenerate. But you'll notice again that the depth per cut is still constant. Oh, we're optimizing the feed rate. Let's turn that off. So basically the way NX uses a scallop height for a Z-level profile operation is it calculates the depth of cut that would give you the specified scallop on a 45 a face that is at a 45-degree angle to the tool axis. So I'm not going to get a 10 thou scallop, or 10 thou scallop anywhere on this part because these faces are less than 45 degrees. This face and this face are more than 45 degrees. So the scallop option is kind of misleading, I guess. At least unless you get into the cut levels dialog box and you change the cut levels to optimized. So with optimized cut levels, what NX is going to do is it's going to actually look at every single face that you're cutting, and it will adjust the depth of cut to give you the scallop that you specified on every face. Now this is basically what it's doing is it's using this number as the maximum scallop height, because you'll notice as we generate this now, so now you can see that NX has adjusted the cut level to maintain that 10 thou scallop on these faces. Obviously in this area, we're going to have less of a scallop. So the scallop is going to change, as you move down this face, but it will never exceed 10 thousandths. So that's what optimized cut levels will do. If you're going to use scallop height for a depth per cut, and you want to make sure that you change the cut levels to optimized instead of constant. Okay, the last feature is cutting between levels. So notice on this part, this is a Z-level profile, and it did not cut any of the horizontal faces at all, and that's just the default behavior for a Z-level profile. It's kind of intended for inclined faces. But if you want to finish every face with one operation, you can tell NX to cut between the levels. And you can actually have a separate step over for the horizontal faces. So if you're using an end mill with radiuses, you can say that you want to use 50% of the tool flat for the step over, and that way you will eliminate any scallop on the horizontal faces. And then what feed on short move, the feed on short moves option you can see in the graphic here, basically what it's going to do is, rather than retract and then wrap it and then re-engage, it will just stay on the part and feed. And so this is just again, this has to do with you know, a smoother tool path. You don't want, you know, a bunch of 30 thou rapid moves. That's hard on the machine and everything else. So, and then we've got a max traverse distance here. This is basically the maximum move that it will convert from you know, a retract, rapid, re-engage to a cut move at the cutting feed rate. All right, so we turn on cut between levels, generate that. And this will cut now all the faces of this part with a single operation. So, all right, so that's it. Good luck, have fun, and we'll see you again soon.